We did support vector machines as well. So why SVM? It requires less computational resource compared to deep learning. It can handle high-dimensional data, and also it was a popular algorithm in image classification a few years ago. And we mainly control three hyperparameters. They are C, kernel, and gamma. So C is penalty parameter of the error term. So when C is large, the hyperplane will be small so that it can classify more records correctly. But in the meantime, there is a risk of overfitting, and the kernel is a kernel type to be used in the algorithm. So the hyperplane sometimes is linear and sometimes is nonlinear, so we want to control it by the kernel. And the gamma is a kernel coefficient. Gamma controls the stretching of the data in the third dimension. Because this is our initial SVM model, so we just use a simple one. We use a default SVM model, but we set gamma to be 0.001, but there is no specific reason for that. We just set a value for the gamma to see the performance. For the pre-processing stage, we did the same process as we did in the boosted trees, and we got the testing result. As we can see, it showed the grayscale model did the best. It got the accuracy of 0.0073, which is quite low, but it's a little bit better than the random guess, which is 0.0053. For the next step, we will definitely do the parameter tuning, and we will use different feature extraction methods to build a model like HOG. We will also use more performance metrics for the evaluations.